Okay, let's begin number 6 from exam 1. Use the intermediate value theorem to show the equation root x plus x equals 1 has a solution in the interval 0 to 1. Okay, to use the intermediate value theorem and to use that to show that there was a solution, we needed to do a couple things. The first thing is we needed to have an equation, or I'm sorry, a function to use in the first place. So what we're going to do is, if this is what I want, okay, this is the same thing as saying root x plus x minus 1 equals 0. So let's let f of x equal root x plus x minus 1. So a solution of this would be a root of my function. Okay. Second thing is the intermediate value theorem. So let's go over here and quickly check this out. If I had two endpoints, and if I were to evaluate a function at, say, 0, and you get a negative y value, and then I evaluate the function at b, and I get a positive y value, then what has to happen in order for my continuous function, which I'll talk about in a second, the continuous function to go from one point to the other? And no matter how it actually goes there, it has to cross the x-axis. And that would be a root. So if x equals 0, because that's the interval I'm dealing with, if x equals 0, what's f of 0? That's root 0 plus 0 minus 1, negative 1. Oh, I did mention continuity. The condition needs the function to be continuous. Root x, continuous, as long as you're not plugging in a negative number. And these are just polynomial terms, which continuous everywhere. So my function is continuous. Otherwise, you're not guaranteed to cross the x-axis if you're not continuous, because you could just jump over the x-axis because of a piecewise function. For example, you know how you can jump from one part to another. Okay, so when you plug in x equals 0, you get a negative y value. If you plug in x equals 1, you're going to get root 1 plus 1 minus 1, that's 1. So, plug in 0, you get a negative y value, much like we did here. You plug in a positive 1, you get a positive y value, much like we did here. So what does that guarantee us? Again, so by the intermediate value theorem, this guarantees us a root must exist in 0, 1. Somewhere. We don't know where. But I know there is at least one root, because I had to have crossed it just to go from here, negative y value, to up here, positive.